Hello dear students, I'm Ajay Karmarkar. Before starting this video, I would like to say something. Please sit with copy pen. If you find somewhere important, then note it and proceed further. And although you have facing any problem or difficulties, please write in comment box. I will definitely solve your problem. And along with, please like, share and subscribe my channel that can reach more and more students. Thank you. Now here is the question. It is a paragraph question. A block capital B of mass small m is suspended from a cord of length small l attached to a card A of mass capital M as shown in the figure. The horizontal surface on which the card moves is smooth. Initially, both the card and the block are at rest. In the position shown, now B is released. Here we have to take capital M is equal to small m equal to 2 kilogram. Here theta equal to 45 degree and g equal to 10 meter per second square. Now first question, the acceleration of the card immediately after the system is released. Here option A 1 by root 2 meter per second square. Option B 10 by 3 meter per second square. Option C 10 by 3 root 2 meter per second square. Option D 5 meter per second square. Now in this question we have considered two systems. First, this is moving object and here a pendulum is connected which having the mass is small m, its mass is capital M. Okay, here this pendulum whenever we have to put and then strikes that it is moving oscillates. So therefore when any object moving object is connected with another, that means some pseudo acceleration is working on it, and due to this pseudo that is act in opposite direction of motion. Is it clear now? So now here this block M working as a pendulum, here the tension working in between this card and this block, that is T. Okay, so here angle is theta and theta is given that 45 degree. So here we have to resolve into components t cos theta and t sin theta. Here t sin theta provides pseudo acceleration or pseudo force. Okay, so therefore t sin theta equal to ma. Okay, and its direction ma is to the left side. And what is the theta? That is sine 45, then 1 by root 2 equal to ma. So t equal to root 2 ma. Okay, here the mass of card and mass of this block is the same. So therefore that is 2 kilogram. So here 2 root 2 a. That is the first equation. Clear? Now we are talking about the second system, that is pendulum, and how to resolve different forces. Please look at carefully. I have made it colorfully. Here let us first we have to talking about the tension. Here the tension acting towards to the card, and here divided into components, that is t cos theta is according to normally, and this t sin theta in forward direction are right side. Okay, so here t sin theta and t cos theta, t sin theta and t cos theta. As you know that when it is released, then it's moved to the forward direction, and that time this here on the card pseudo force is acting on it, and that time it become non-inertial frame because it is moving. That time it will be moved. So therefore ma is acting forward direction, and we have to divide two components in the direction of t, that is ma sine theta, and here theta is 45, and here ma cos theta, ma cos theta. Okay, I have override because I think so red impression is not quite well, so therefore ma cos theta. Okay, and here mg is also resolved into component, that is mg cos theta, and here mg sin theta. Okay, I think so you understand all the forces of to resolve. Again, t is here, t is resolving two components, that is t sin theta in forward direction, t cos theta in upward direction. Here ma, m here is mass of this pendulum, that is small ma. It is also resolved in two components in the direction of t, ma sin theta and ma cos theta. Okay, and here mg is also divided into components, mg cos theta, mg sin theta. Okay, now initially this t plus ma sin theta equal to mg cos theta. We have to talking about the initially. It means that time instant position means velocity is doesn't matter, velocity is zero. So therefore t plus ma sin theta mg cos theta. What is theta? Theta is 45. So sin 45 is 1 by root 2. So ma into 1 by root 2. Here mg, that is also 1 by root 2. And t we have already find out 2 root 2a, that is 2 root 2a, and here ma by root 2 equal to mg by root 2. Okay, now solving root 2 root 2 2 2 2 are 4a plus ma by root 2 equal to mg by root 2. This is root 2 cancel. Here ma, here m is given, that is 2 kilograms, so 2a, here 2 into g, that is given, that 20. So here 6a 20, then a equal to 20 by 6, 2 3s are 6, and that is 2 10s are 20, then a equal to 10 by 3 meter per second square. And what is t? T equal to 2 root 2a, then substitute this value 10 by 3, then t equal to 20 root 2 by 3 Newton. It is second condition. Now next part, we have to find out the question, the magnitude of acceleration of b with respect to card immediately after the system is released. You know that here the system is released. That time this acceleration, this force gives centripetal force. So here centripetal force mv square by r, or we can say that that is equal to mg by root 2 ma by root 2, or it can be written as ac, centripetal acceleration, because we have to find out the acceleration. M get cancelled, so here g by root 2, and here a by root 2. So what is the value? That is 10 by root 2. And what is the value of a? That is 10 by 3, and that is root 2. Taking the LCM, 3 root 2 and 30 plus 10, that is centripetal acceleration 40 by 3 root 2 meter per second square. So here the first question, the acceleration of the immediately after the system is released from the rest, that is option B, 10 root 10 by 3 meter per second square. And second question, the tension in the immediately after the system is released from the rest is here the option D, 20 root 2 by 3 Newton. And last, the magnitude of acceleration of B immediately after the system is in rest is here the option 40 by 3 root 2 meter per second square. I hope so you understood this question. Thank you. Thank you for staying till the end of this video. Definitely for your success, all the credit goes to your hard work. But if my video will help for your success, then I will consider myself lucky. Thank you once again. Take care. Bye bye.